Hello students, welcome back. This is Bittu Sharma, your physics mentor. Students, first of all, I welcome you in the crash course of your JEE Mains by Extramarks. And in this today's session, we are going to discuss a new chapter in your crash course of JEE Mains exam. The chapter is Mechanical Properties of Solids. So before starting the chapter, I would like to tell you the importance of this chapter, students. So this chapter is very important for your exam point of view. Why? Because every year at least one, yes or no, we know that yes, 25 questions regularly they are asking, 25 questions they are asking in our JEE Mains exam. So out of those 25 questions, at least one you will get, one question you will get from this chapter, Mechanical Properties of Solid. Other thing which makes this chapter important is, students, this chapter is very easy, as well as the number of concepts in this chapter are very less. So if you have less number of concepts, so you can prepare it well, and like it will give you a bonus marks. I hope you are getting this. So without wasting any time, I would like to start the session. So the first topic which we have to, so before starting I'll tell you what and all we are going to cover in this chapter. First we will discuss about elasticity, then we will discuss about stress, strain, modulus of elasticity. After modulus of elasticity we will discuss like stress strain curve, Poisson's ratio. After that we'll discuss about thermal stress, and in that way we will wind up the chapter, and this all we have to cover in 1 hour. I hope you are getting. And with these all concepts, students, I have very important numericals which we will practice in this today's session. Important for your exam point of view. We have analyzed here everything. The questions which are in trend, those questions only I have taken for you. In this question, most of the questions I have taken from your last few years JEE Mains exam. So I'll start the session. The first concept which we have to see here is elasticity. Okay, so what is elasticity? Again, in this session we have very less period, very less time, so I'm not going to tell you any derivation or the definition, because here I'll tell you the concept, brush up on all the concepts, all the important formulas, and then we will solve important numericals. Okay, so what is elasticity? Elasticity is nothing but, students, the property of material, the tendency of any material due to which it will regain its original shape after removal of deforming force. So remember this thing, what? After removal of deforming force, if a body will again regain its original shape, that tendency of any body, that property of any body is called as elasticity. So I am writing here tendency or property of material due to which it regains its original shape after removal of deforming force. So I hope you know very well about this deforming force. Deforming force means what? The force due to which the body can deform. So after removal of deforming force, students, the tendency of any body to regain its original shape is called as elasticity. Okay, now based on this elasticity, I am going to tell you about stress and strain. Okay, so what is stress, students? You have to understand what is stress. Stress is nothing, again I am not going to tell you the formula, only tell you the definition, only the concept. Stress is what? Nothing but restoring force divided by unit, divided by area. So remember this thing. Most of the students doing mistake here. What if anyone ask what is stress? Their answer is stress is nothing but force by area. So force by area is not the stress. Remember this thing, students. Stress is what? Restoring force per unit area. Now what is restoring force? This you have to understand. So suppose you have any rod here, suppose you have any cylindrical rod, okay. So I'm drawing here the diagram, you can see on your screen. So here I have a cylindrical rod, and what I am applying a compressive force on this. What I am applying a compressive force on this. Okay, and this value of force is very small. The force which I am applying on the rod, this force is very small right now. So I am writing this, it is compressive force, and from outside I am applying this, so better I will write it as external force. Getting or not? What I am writing, this F is external force, and right now this value of external force is very small. Okay, now students, do you think that it's a iron rod? So do you think that there will be any change in shape of iron rod? No. Why? Because the external force is very small, due to which due to that force there will be no change in the shape of or in the length of iron rod. Getting or not? Now the question arises, why the shape of iron rod is not changing? Getting or not? Instead of iron rod, if I will take the same identical rod of any you can say thermocol or any object, getting or not, which we can easily deform. Getting? So that body, that the rod shape or dimension of that rod will easily change, but shape of iron rod is not changing here. The reason is here iron rod is applying some restoring force. Getting or not? So iron rod is applying some restoring force, Fr. Getting or not? So remember this thing, what is restoring force? Restoring force is the force applied by a rod itself which opposes the external force. Getting or not? If from outside, if we will try to pull the rod, getting or not, so restoring force will be opposite to the direction of external force. So I hope you are getting this, students. So in most of the cases what restoring forces, most means 95% questions which we will get in our syllabus, in most of the cases restoring force will be equal to the external force. Okay, so restoring force will be equal to external force, so that's why we will directly write stress is equal to force by area. But remember this thing, stress is not force by area, stress is restoring force per unit area. So I hope you are getting this, students. Again I am writing here in after some time I itself will write stress is equal to force by area. I will not write again and again that stress is restoring force. Means there it is understood that restoring force is equal to the external force. Okay, so now the next thing which we have to see is strain. Okay, so first I will tell you how many types of stress we have. Okay, so stress we have basically of three types. The first one is longitudinal stress. First is what, students? Longitudinal stress. Now what is longitudinal stress? Example which I gave right now is an example of longitudinal stress. Again I will tell you what. Suppose I have a rod, and if I will try to if I will try to change the length of rod, getting or not, I am applying force along its length. Getting? If I apply force along its length, then what? Then the stress developed in the rod is called as longitudinal stress. So longitudinal stress are of two types. The first one is tensile stress and another one is compressive stress. Okay, so I'll write here tensile and compressive stress. Types of longitudinal stress. What? First one is tensile. So A I am writing tensile, and B I am writing here compressive stress. So it's a crash course. I hope you all know these basic things. Getting? After explaining this directly, we will solve the numericals. So suppose this is a rod, and if suppose we are applying to increase its length, we are applying force on the rod such that its length increases. This type of stress developed in the rod is called as tensile stress. So if you see, the next new length of the rod will become this. I am drawing by black color. You can see here the black color shape of rod is the new shape after applying of external force. Okay. Now in the same way, what is Compressive stress is nothing. The force which we will apply on the rod along its length will try to decrease the length of rod. Again I am repeating, the force which we are applying on the rod along the length of rod will try to decrease the length of rod. That type of, now the stress developed due to this force inside the rod is called as compressive stress. But remember, the formula of longitudinal stress is remain same. What? Force per unit area. And which area we will write here? Stress is equal to force by area. Again it is restoring force. And which area we will take? The cross sectional area of the rod. So I am writing here force. Which force? Restoring force divided by area of cross section. Okay. Now the next type of stress, students, which we have is tangential shear stress. Now what is shear stress? Suppose here, students, I have a block on any surface. It's a cubical block. So I am drawing only the two-dimensional shape, you can understand, and it is the front view which I have drawn. Getting or not? You can see on your screen. And if I apply force, tangential force on this block. Tangential force means on this upper face. I am applying force in this direction, due to which, students, what maybe the shape of block will be like this. See this black dotted shape, you can see. This will be the new shape of the block. Now what shear stress means? Shear stress formula will become, again it will be force per area, but which force it will be? It is tangential force. Getting or not? Shear stress is what? Shear stress is nothing. Tangential force, Ft divided by area. Now which area? This area we will take on which we are the face of the area of face on which we are applying tangential force. Okay. And the third stress is volumetric stress. Third stress is what? Volumetric stress. Now what is volumetric stress, students? Simple. You can think here, suppose I have a bucket of water, a bucket filled with water, and suppose I have any object of any dimension. And if I dip that object inside the bucket, you can say bucket filled with water. Getting or not? So what? The water exert pressure on each and every point of the object. Suppose this red color thing you can see here, you can consider it as object. Let us take an example of any ball. Okay. Now what? The water will apply pressure at every point of the ball, due to which the ball will maybe it will compress. Getting or not? Due to which the ball will compress. So here you can see the entire volume of the ball is going to decrease, and due to which the stress developed in the ball is called as volumetric stress, and its formula will again, so remember this thing, it is not like this. If it is volumetric stress, so we will write force per unit volume. No, the formula will remain same, force per unit area. So this is an example which I already given to you for volumetric stress. What? But formula will remain same, what? Force per unit area. Okay. So this was all about stress. The next thing which we have to discuss is strain. What is a strain, students? Strain is nothing. The basic formula of strain is change in dimension divided by original dimension, or you can say change in length, change in dimension per unit dimension. Getting or not? So I am writing here change in dimension per unit dimension. Yeah, we can write original dimension. So like stress, students, strain also we have of three types. First is longitudinal strain, second is shear strain, and third is volumetric strain. So first I will tell you about longitudinal strain. Now what is longitudinal strain, students? So you can see I already told you in longitudinal stress the force which we are applying, either it's external force or its restoring force, both the force are acting along the line, along its length, due to which only the length will change. Getting or not? So longitudinal stress is what? A change in length per original length. Change in length by, if we will apply force along its length, then length only will change. So change in length per original length. Yeah, change in length per unit length, you can write original length. So this is what longitudinal stress. Either it is either it's a tensile stress, or it is compressive stress. Whatever it is, the formula will remain same. What? Change in length per original length. Second kind of stress strain which we have is what? Shear strain. Shear strain. So shear strain, you have to focus here, students. In most of the questions we will use only tangential longitudinal strain, but shear strain also you have to focus. Now what is shear strain? See, again I will take the same example. We have a block of lying on any surface, and here on this diagram I am drawing only the front view, means the 2D shape. If we will apply tangential force like I have drawn, you can see due to which the new shape will be like this. I will draw here. New shape will be like this. Getting or not? So you can see here, this will be the delta x, you can say the length, it is changing, and here it is length L. Yes, side A. Getting or not? Let us say this is an angle phi. So what will be shear strain, students? Shear strain is nothing. Shear strain we will represent by E. Getting? Like this. So shear strain will be nothing but delta x divided by L. Now delta x is this length divided by L. Getting or not? And delta x by L. Now in this triangle, you can see, if I write the name ABC, in this triangle ABC, this, if you calculate the value of tan phi will also be delta x by L. You can write as tan phi. And this, you can understand, students, this value of phi will be very small. Getting? This phi, because if we have a solid object, a solid block, suppose block of iron, so you cannot deform it that much. Getting or not? So this value, if value of phi is very small, then tan phi will be approximately, students, you can write as phi, and this will be your shear strain. Okay, the next and last type of strain is what? The last is volumetric strain. So third I am writing volumetric strain. Volumetric strain means change in volume per original volume. So delta V by V. Again I am writing change in volume per original volume. Volumetric strain is change in volume per original volume. Okay. So this is volumetric strain. I hope, students, you are getting this. Now the next is modulus of elasticity. So remember this thing, students. You all know modulus of elasticity means nothing. See, up to the elastic limit, I will tell you when I will teach you the stress strain curve. So what is elastic limit? But remember here, up to elastic limit, students, what? Up to elastic limit, stress is directly proportional to strain. Now I cannot go in depth, because why? We have very less time. In 1 hour we have to finish. Stress is directly proportional to strain. So if I'll remove this proportionality sign, I have to add some constant capital E. This capital E is called as modulus of elasticity, and its formula will become stress by strain. E will become what? Stress by strain. So remember this thing, modulus of elasticity we will get when up to the elastic limit. This stress is directly proportional to strain is nothing but Hooke's law, and this Hooke's law is valid only up to elastic limit. Okay, so Hooke's law, Hooks, I'll write here Hooke's law, and it is valid up to elastic limit. So what is elastic limit? I will tell you when I will teach you what you can say stress strain curve. So if I will talk about tangential stress and tangential strain, longitudinal stress and longitudinal strain, because most of the time we have to discuss about that only. So longitudinal stress is what? Force per unit area. Again, I'm not telling what it's restoring force, because it's obvious. I already told you, whenever I'm telling about stress as force per unit area, it means it is restoring force only. So restoring force per unit area divided by strain is what? Change in length by original length. Getting or not? So this will become Young's modulus of elasticity. So like stress we have of three types, strain we have of three types, modulus of elasticity also you can say we have of three types. The first one is what? Young's modulus. So I'll write here Young's modulus of elasticity, or directly I'll tell we can say Young's modulus. Getting? So first one is Young's modulus. And Young's modulus we can represent by capital Y. Now what is Young's modulus? Longitudinal stress divided by longitudinal strain. Now what is longitudinal stress? Force by area. Longitudinal strain is change in length by original length. If you simplify this, what we will get? Force into length divided by area into change in length. Area into change in length. So FL by A delta L, this will be the value of Young's modulus. Getting or not? Now the second is shear modulus. Second is what? Shear modulus. So shear modulus is what? Shear stress divided by shear strain. It's again very simple. Shear stress divided by shear strain. So you can derive formula by yourself. It's very easy. One example I gave for a longitudinal stress, shear stress by shear strain. Now what is shear stress, students? Already we have discussed. Force by area divided by shear strain is what? Delta X by L. Getting or not? So it will become F by A into del L by delta X. F by A into L by delta X. Or what is delta X by L? Delta X by L is nothing. Again, it's the angle phi. Yes or no? I explained in the last slide. You can see here shear strain. What? L delta X by L, and it is phi only. Getting? So the next is, after shear stress we have the third type of modulus, that is called as bulk modulus. What? Bulk modulus. And the shear modulus is also known as modulus of rigidity. Modulus of rigidity. It is represented by G, modulus of rigidity. Okay. The third one is bulk modulus, and bulk modulus is represented by B, and its formula is what? Bulk modulus means volumetric stress divided by volumetric strain. So volumetric stress is force by area divided by volumetric strain will be what? Change in volume divided by original volume. So this you can define all the types of stress by either it's. So now this force per unit area, students, if the force which we are applying on the entire surface area of the object, like I gave example when we dip a ball inside the bucket filled with water. So this force per unit area will become what? Pressure into V divided by delta V. And here we will use one minus sign also. Why? Because the volume here is going to decrease. So it will become minus PV divided by delta V. This is the formula of bulk modulus which we have to use in our numericals. I hope you are getting this, students. Now based on these concepts, I have one very good numerical for you. What they are saying, two blocks of mass 4 kg and 2 kg are connected by a metal wire going over a smooth pulley. Okay, so first I will draw a diagram here. We have a pulley connected by a string, and fixed by that string is fixed by the roof. Okay, now the another metal wire is connected by two blocks of masses 2 kg as well as 4 kg. Okay, 2 kg and 4 kg. The breaking stress of metal wire is given to us. Now what is this breaking stress, students? You have to understand, breaking stress is the maximum stress that a wire can bear. Means if we will apply, if the stress in wire is more than breaking stress, then what? It will break. So breaking stress is given to us how much? 2 into 10 to the power 5 Newton per meter square. In question they are asking the minimum cross section area of the wire so that it does not break. Okay, you can see here students this type of arrangement in the diagram which I have drawn, this type of arrangement which we have here. Now because both the masses are different, so this 4 kg mass will move downward and this 2 kg mass will move upward with acceleration a, and there will be some tension in the metal wire T. So first of all we have to calculate the value of tension. Now value of tension you can calculate by our general method, by our conventional method. First we have to write the equations and all, or here I will tell you a short trick. I am not going to tell you the conventional method. See, remember this thing students, how much force will act here downward on 4 kg mass? It will be its weight 4g, and similarly on 2 kg mass it will be 2g. So the net force acting, suppose if I place this system on a table, so these are two masses 4 kg and 2 kg. This 4 kg mass is pulled in this direction by force 4g and 2 kg mass is pulled in this direction by force 2g. You can see here the net force acting on the system is how much? The net force acting on system is, it will be 2g towards right, due to which the entire system will move towards right with the acceleration a. So first of all we have to calculate acceleration. Acceleration is nothing but force by mass, F is equal to ma, so a you can write as F by m. Now how much force is acting? Net force acting is 2g divided by total mass of the system is 4 plus 2, that is 6. So acceleration we will get as g by 3. Now I am repeating, I'll tell you one sentence. If you focus that, if you concentrate on that sentence, you can solve each and every question based on pulleys which you have solved in the chapter Newton's laws of motion very easily. Okay, so this 4 kg mass wants to move with acceleration g by 3. So how much force it will consume? The force consumed by this 4 kg mass is m into a, where mass is force and acceleration is g by 3, means 4 into g by 3. So net force acting on this 4 kg mass is 4g minus consumed force is how much? 4 into g by 3. Remaining amount of force will be how much? 4 3s are 12 minus 4, it will be 8g by 3. Means the value of tension easily we can calculate as 8g by 3 without writing any equation. So this is short trick which I want to tell you students. Okay, so tension we got how much? This tension is 8g by 3, and this tension itself will act like a force in the wire. Getting or not? Tension will act like a force in the wire. Okay, so here I will write stress is nothing but force by area, and force here is like what? Which force it is? It is tension force. And tension how much we have calculated? We have calculated 8g by 3 divided by area. Now we have to calculate the minimum area, so the stress we have to write here maximum, what? Breaking stress, which is given to us how much? 2 into 10 to the power 5 Newton per meter square. Okay, so stress I am writing as breaking stress 2 into 10 to the power 5 is equal to 8 into value of g I am writing 10 divided by 3 divided by area. Okay, so area we will get here students 8 into 10 to the it will be 8 tens are 80. Getting or not? So directly I'll write 8 into 10 divided by 3 into 2 into 10 to the power 5. I hope you are getting this students. So if you solve this, what it will become 4. So 4 by 3 into 10 to the power minus 4 means 1.33 into 10 to the power minus 4 meter square will be the minimum area. If you want to write in centimeter square, so 1.33 centimeter square will be the minimum area of cross section of the metal wire which we required, so that it will not break up to the breaking stress of 2 into 10 to the power 5 Newton per meter square. I hope you are getting this students. Question was very easy. The only thing is it was conceptual. I want to give you the concept of how to solve pulley types questions and how to solve breaking stress types question. That's why I have taken this question in front of you here. Okay, the next question which I have for you is, Find the extension in a wire of length L, cross section area A, mass M, and Young's modulus of elasticity Y, or you can write gamma sometimes, under its own weight. So remember here, what we are not applying any force. Simple thing, suppose we have a wire and the shape of wire will be cylindrical, of course. Yes or no? Shape of wire will be what? Cylindrical. So I will draw here, we have a wire, okay, and the mass, length, area, Young's modulus of wire, everything is given to us, and this wire is in hanging position. Mass is M, area is A, length is L, Young's modulus is Y. This wire is in hanging position, okay. Now due to its own weight, students, what the length of wire will increase. You can feel here weight will act downward, and due to its own weight its length will increase, and that length we have to calculate the extension in the wire due to its own weight, okay. So most of the students, what they will do here, already I told you the formula of you can say change in length is what is, they will directly write change in length is directly what, Young's modulus Y is F into delta L divided by A into L. So from directly here they will tell delta is nothing but Y A L divided by F they will write M into G, where M is its mass. Getting or not? F they will tell directly M into G. By downward force, what it will act? It will its own weight only. But students, try to understand, this concept will fail here. It will not be the correct answer. Now how to solve this question, I will tell you. First of all, you think the force, the weight acting on each and every cross section of this wire will be same. Do you think that it will be same? No, it will not be same. Why? Because suppose I have taken the lowermost cross section, this cross section. Now you have to think which part of wire is pulling this cross section downward. No, there will be no force on the lowermost cross section of the wire. Why? Because below that cross section nothing is there, so that it can pull that cross section. Getting or not? And at the topmost cross section of the wire the force will be maximum. On topmost cross section the force will be M into G, but you cannot say that everywhere force will be M into G. So the next thing is how we can solve these types of question. Now what we have to do, we have to take a elemental cross section anywhere in the wire at a distance of x from its bottommost part, and the length of wire, let us say the length of elemental you can say cross section is dx. Getting or not? Now first of all we have to calculate the change in length in the elemental wire, okay. So change in length of elemental wire, let us say it is dl, and value of dl will be how much, students? Value of dl you can write as Young's modulus Y will be same A, okay, and dl will become delta L. See, stress is what? Young's modulus will be Y is equal to what? Stress by strain. Stress is force by area, strain is delta L by L. So it will become, it will be L by delta L. Yes or no? It will be L by delta L. So here I will write L. So delta L it will come here, and L. So from here, students, delta L you can write directly, instead of mg I'll write here force only. So delta L you can write as F into L divided by YA. Getting or not? So here dl will become F, force on the on this elemental cross section, into original length of this elemental cross section is dx, divided by Young's modulus Y, area of cross section A. Now the next thing is how we can calculate force. For that, first of all we have to calculate force per unit area. So on the entire rod, students, mass is how much? M, divided by the length of rod is how much? L. So this is mass per unit length into x, because this cross section is, I'll try again draw the diagram here. This cross section is x unit, x meter or whatever unit is there above its bottommost part. So this is only x. So you can think here, this x length only will pull this dx downward. Getting or not? M by L into x, getting, into G. So mass into weight, it will become the force acting on this elemental part. Okay, so this is value of force. If we will substitute in value of dl, so dl, what we got here, dl we got f dx divided by ay. So dl is f dx divided by ay, and instead of f I am write m by L into x into G into dx divided by ay. Okay, so I will take now to calculate the total length I have to integrate it. So change in length in small elemental part dx will give you the total change in length delta L. M I will take out, original length L I will take out, G I will take out, divided by ay I will take out because it's all are constant, and integration of x dx, and limit will be, students, limit of x is 0 to L because the total length of wire is how much? It is capital L. So it will become m by L G by ay into integration of x is what we all know, integration of x dx is x square by 2, and if we will substitute the limit, I will directly write here, it will become L square by 2. So L square by 2 I'll write after substituting the limit, and this is square and this L will get cancelled. Final answer what we will get, mgl divided by 2ay. This will be the correct answer. Getting or not? Now I saw some few of the students, they will directly get this formula. What they will think, they will take center of mass concept. Getting or not? They will take center of mass at the center of rod, and then they will say length will become L by 2. But no, students, don't do this, because here it's coincidence what, that because in the it's a uniform shape, the object is of uniform shape, it's a cylindrical wire, that's why we are getting this answer. But suppose if you will get a body of non-uniform shape, then you will not get the correct answer by that method. So this derivation is most important. Why? Because in our JEE exam we are getting number of questions based on this, where the density of the material wire will not same. Getting? If density of material wire is same, then you can directly use this formula mgl divided by 2ay. But if density is not same, then again you have to completely go through with the derivation. I hope you are getting this. I am moving towards the next question. So the next question I have for you is, average depth of an Indian Ocean is 300 meter. Okay, calculate fractional compression of water at the bottom of ocean. So suppose at the bottom of ocean we have a water molecule on which other water molecule are applying compressive force. Yes, getting or not? Because the pressure inside the ocean will be huge. Pressure inside the ocean at the bottom depth of the ocean, pressure will be more, due to which the volume of water molecule will decrease, and you have to calculate a fractional compression of water. Getting or not? Now how we will solve this question, students? So here we have to use concept of bulk modulus. Bulk modulus, already I told you, bulk modulus B is what I'll use here. B, bulk modulus B is what? It will be P into V divided by delta V. Getting? We have derived this. Again, bulk modulus is volumetric stress by volumetric strain. Volumetric stress will be equal to pressure, and volumetric strain will be delta V by V. Getting or not? So delta V by V, if we will reciprocate it, it will become V by delta V, and bulk modulus we will get as P into V divided by delta V. Now the next thing is, we have to calculate the pressure at the bottom, at the depth of Indian Ocean. Getting? So pressure formula we know that it is rho GH. Now density of water is not given to us because it's very common. We know it is 10 to the power 3 kg per meter cube. 1000 kg per meter cube into value of acceleration due to gravity, let us say it is 10, and H, depth, how much it is given to us? 300 meter. So if you solve this, students, how much we will get pressure? Pressure at the depth of 300 meter we are getting as 3 into 10 to the power, so 3 plus 1 4 plus 2 6. Pressure we are getting 3 into 10 to the power 6. Okay, this value of pressure we will substitute here in the formula of bulk modulus. So we will get fractional compression of water. Getting? Now bulk modulus is what? Bulk modulus is given to us. It is 2.2 into 10 to the power 9. So I'll use different color here. You can easily understand. 2.2 into 10 to the power 9 is equal to, pressure is how much? 3 into 10 to the power 6 into volume divided by change in volume. Now you have to calculate fractional compression of water. What is fractional compression of water? So try to understand, students. Fractional compression is nothing. They are saying change in volume divided by original volume. This is fractional. See, simple, they will say if you have to calculate change in volume means delta V you have to calculate. But if they are using the word fractional, means you have to calculate change in volume divided by original volume. So change in volume delta V divided by V, it will become from here as 3 into 10 to the power 6 divided by 2.2 into 10 to the power 9. So this simple calculation you can do by yourself. I am leaving here. It's simple calculation, students. I hope you can do this and you are getting this question. Getting or not? So this was very easy question, but the concept was more important. Now the next concept which I have for you is a stress strain curve. So this is stress strain curve you have to understand. Students, stress strain curve in depth you will understand, you will study in your engineering, especially if you are going with mechanical engineering. But I'll tell you, whatever we have in our concept here, only very few concepts related to stress strain curve which we have. So suppose we have any object, any rod, and if we will apply some force on that rod, due to which restoring force will develop, and due to restoring force, students, stress will develop in the rod. So stress and strain, if we will draw the graph in between stress and strain of that rod, it will be like this. So this will be stress and strain curve. Getting? This point I am writing A, this point I am writing as B, this point I am writing as C, and this point I am writing as D. So try to understand, there are few more points, but the other points are not in our syllabus, so that's why I am not writing. You will study again in detail in your engineering. So what is this point A? This point is, the point A is called as proportionality limit. Proportionality limit. Proportionality limit means up to point A, students, is what? Stress will be directly proportional to strain. Means what? It is Hooke's law, which I already told you when I started this lecture. Getting or not? Stress will be directly proportional to strain. This is proportionality limit, Hooke's law. Getting or not? What is point B? Point B is nothing but, point B is what? Elastic limit. Point B is elastic limit. Now what is this elastic limit? Try to understand. After A, students, if we will apply some more force on B, then what? Length of the stress will increase as well as the strain will increase, but stress will not directly proportional to strain. But one more thing is there, that if you remove your deforming force, if you remove the deforming force up to point B, body will again regain its original shape. Getting or not? Body will again regain its original shape. So body can regain the original shape. Body can regain the original shape. So this is point B. And up to point B, students, this complete region is called as elastic region. This complete region is called as elastic region. What is point C, students? Point C is nothing but the breaking stress. Breaking stress means after point C, if we will again increase the stress or decrease the stress also, the wire will break. Breaking stress. Now what is point D? Point D is rupture point. Point D is what? Rupture point. Getting? Rupture point means at point D, the wire will break. See, at point C it is breaking stress, but at point C wire will not break. At point C it is not going to break, but it is decided at point C that now hereafter, either if you increase the stress or if you decrease the stress, wire has to break. There is no possibility that wire will remain sustained. Getting or not? And finally at point D, the wire will break, and that point D is called as rupture point. Getting? Now I'll tell you some property of ductile, elastic and a ductile material, brittle material and elastomers. What are ductility, what is ductility? So this and all you have already studied. I am not going to give you the definition. Ductile material, students, for ductile material, plastic region is more than the elastic region. Plastic region means if you apply some force on the ductile material, they will not regain their original shape. They will be in that shape only. Getting or not? Means their plastic region is more than the elastic region. Again we have brittle material. What is brittle material? For brittle material, students, plastic region is very less and elastic region will be very small. Plastic region will be very small. Brittle material is just like, you can say, chalk. If you try to pull the chalk, it will not change its length, and before itself it will break. Getting or not? So that is brittleness. Plastic region is very small. The last one is elastomers. Now what is elastomers, students? In elastomers there is no plastic region. Everything which we have will be elastic region. Means what? If you try to pull it continuously, you are pulling it and its length is changing. There is no plastic region. Like a rubber band, if you pull rubber band and after that if you will release it, again it will regain its original shape. So these types of material are called as elastomers. The most important concept next is energy stored in stretched wire. So I am not going to tell you the derivation. Directly remember formula. Energy stored in stretched wire formula, we are representing it by U, and its formula is what? 1/2 into stress into strain into volume. Getting or not? So this will be the formula of energy stored in a stretched wire. But in most of the question, what we have to calculate? We have to calculate energy stored per unit volume, and this energy is potential energy. That's why I am representing it by U. Potential energy. Getting or not? So potential energy stored per unit volume, we have to calculate, and it will become 1/2 into stress into strain. So generally we have to use this formula. Now you can modify this formula also. What we know, modulus of elasticity is what? Stress by strain. So from here, stress is nothing but stress will be what? Stress is E into strain. Stress is what? E into strain. So instead of stress, I'll write into E into strain, again into strain. So it will become 1/2 into E into strain square. 1/2 into E into strain square. This will become. In the same way, students, if you calculate U by V and you change this E is equal to stress by strain, instead of calculating value of stress, you calculate value of strain. It will become stress by E. Strain will be what? Stress by E. So instead of writing the value of strain, you can write stress by E. So 1/2 into, instead of stress will be stress only, and strain you can write as stress by E. So it will become 1/2 into stress square divided by E. So these all are few basic formulas of potential energy stored in a stretched wire per unit volume. Okay. Now based on this, I am going to write the values. Next is Poisson. I am going to tell you next concept, Poisson's ratio. Poisson's ratio, students, we will represent it by sigma, and it is very basic concept. Direct formula is what? Lateral strain divided by longitudinal strain. So lateral strain divided by longitudinal strain is Poisson's ratio. I hope you are getting this. Now what is lateral strain? I will give you with an example. Suppose we have a wire, and if we will pull the wire, then definitely what? Its length will increase, but at the same time, students, its radius will also decrease. Getting or not? If we will pull the wire, then its length will increase, but its radius will decrease. Means what? Its length as well as area of cross section, or you can say radius both are going to change. So there will be two types of strain in that case. The one will be lateral strain. Lateral strain means change in radius or change in cross section area per unit cross section area, divided by longitudinal strain. Longitudinal strain means change in length per original length. So sigma will be, lateral strain will be what, students? What you can write as lateral strain? Simple, delta R divided by R divided by longitudinal strain will be delta L divided by L. Now here you can understand the length will increase but the radius will decrease. Both are in opposite sense. Length is increasing but radius is decreasing. So because of that we will use here a sign minus. Getting or not? Due to which we'll use minus. So you can write as sigma is nothing but lateral strain by longitudinal strain. Lateral strain is delta R by R, negative of delta R by R, and longitudinal strain will be delta L by L. This is only the Poisson's ratio. That's all. Nothing is there in that. Okay. Next question which I have for you is problem number 4 is what? The Young's modulus of brass and steel are 10 into 10 to the power 10 Newton per meter square and 2 into 10 to the power 11 Newton per meter square respectively. So this Young's modulus, value of Young's modulus of steel and brass wire is given to us. This question is from your previous year JEE Mains exam. Young's modulus of brass, how much? It is 10 into 10 to the power 10. It is 10 into 10 to the power 10 Newton per meter square. In the same way, Young's modulus of steel is how much? 2 into 10 to the power 11 Newton per meter square. This data is given. A brass wire and steel wire of same length are extended by 1 mm under the same force. So their initial length is same. The force which we are applying on the wire is same. And change in length is also same, that is 1 mm. We have to calculate the ratio of radii of the brass and the steel wire are RB and RS respectively, and options are given to us. We have to calculate relation in between their radius. So students, why we know that stress by strain, stress is force by area, strain is change in length by original length, force by area, change in length by original length. So it will become FL divided by A delta L. So for steel we will write YS and for brass we will write YB. Okay, and this is area of steel. I will write FL divided by area of brass into delta L. If I divide both the equations, students, both the formulas, in question they told that force is same. In question what they told? That force is same. So F will get cancelled here. Original length is also same, it will get cancelled. Delta L, change in length also they said that it is 1 mm, so that will also get cancelled. Only area of cross section we will get here. Now YS divided by YB, Young's modulus of steel divided by Young's modulus of brass, we will get as AB divided by AS. Now area of B is, because the wire will be of cylindrical shape, so cross sectional will be pi r square. So pi RB square, capital R I should use, because in formula they have given, because in options they have given capital R. RB square divided by pi RA square. So pi and pi will get cancelled. What is YS? YS is 2 into 10 to the power 11, and what is YB? 10 into 10 to the power 10. So YS I will write 2 into 10 to the power 11. So 2 into 10 to the power 11 divided by 10 into 10 to the power 10 is equal to what we have? RB square by RS square. So RB square divided by RS square. If you simplify this, students, it's very easy. It will be if you reciprocate it better. So or 1 by 5 it will become 0.1. Better you do what? So if you reciprocate it, it will become 5 into 10 to the power 10 divided by 10 to the power 11. So 10 to the power 10 and 10 to the power 11 will get cancelled. It will become 1 by 2 only. Finally, how much it will become? Directly I will write 1 by 2 is equal to RB square divided by RS square. So from here RS square will be equal to, RS square is equal to RB divided by 2. And if you remove this square, we will get here under root. Okay, so RS will be what? It is RB by under root. Now you can check which option is correct. Option B is the correct answer for this question. You can see how simple this question is, and they asked this question in our previous year JEE Mains exam. So like that questions only students they are asking. And again I am repeating, this chapter it can be a bonus chapter for you, getting or not. You can easily solve these questions from this chapter in a very short period of time. Now the next concept which I have for you is based on thermal stress. What is thermal stress, students? Remember this thing. Suppose we have a rod, okay, its length is L, area of cross section A, Young's modulus Y, mass is M, everything, okay. Now it is not bounded right now, it is not bounded by any from its cross section. If we increase the temperature, students, then what? Its length will increase. Due to increment in temperature, its length will increase. Getting? There will be change in length. Length increases. Okay. So if length will increase, what do you think that there will be any restoring force in the rod? No, there is no restoring force. Why? Because we are allowing the rod to change its length. But suppose if instead of allowing it, what we will do? We will fix two walls in between. We will fix two walls, and in between the walls we will fix this rod. Then what? And then we will increase the temperature. Then what? Rod will try to increase its length, but because of this wall will not allow this rod to change in its length, due to which stress will develop in the rod. Getting or not? And that stress is called as again restoring force. That stress is called as again what? Longitudinal stress. But it is because of temperature change, so we will call it as thermal stress. What we will call? Thermal stress. So for thermal stress, first of all you have to calculate the value of change in length due to increase in temperature. So directly I am telling you the formula, I am not going to derive it. Change in length is what? L alpha delta T. What is L here? L is nothing but the original length. L is what? Original length. What is alpha here, students? Remember, alpha is coefficient of linear expansion. Coefficient of linear expansion. Getting? Alpha is coefficient of linear expansion. In the same way, with alpha we have beta also coefficient of areal expansion, and gamma also coefficient of volume expansion. So about that and all we will discuss in the chapter heat transfer, but here you have to remember this basic formula. L is equal to delta L is equal to L alpha delta T. Delta T is change in temperature. Suppose the original temperature, initial temperature is 20 degrees Celsius and the final temperature is 50 degrees Celsius. So change in temperature will be 50 minus 20, that is 30 degrees Celsius. Getting or not? Now based on this concept I have one question for you. It's very easy question, and again this question is from your I think last to last year of JEE Mains exam. What? A rod of length L at room temperature and uniform cross section area A is made of metal having coefficient of linear expansion alpha. So all are general notations, I am not going to write this. It is observed that an external compressive force F is applied on its end prevent any change in length of the rod. So what they are saying, instead of fixing rod in between the walls, we are applying some compressive force F, due to which its length is not changing. Why? Because simultaneously we are increasing the temperature by delta T Kelvin. We are increasing the temperature. If we will increase the temperature, rod will try to increase its length, but at the same time simultaneously we are applying external force on the rod, due to which what? Its length will remain constant. Okay. So what? The change in length due to change in temperature will be compensated by, again I am repeating, focus on my words, change in length, increase in length due to, you can say, change in temperature due to increase in temperature is compensated by this external force F. So this concept only I am going to use here. What will be value of delta L? Delta L is nothing but L alpha delta T. Okay, Young's modulus Y is what? Stress divided by strain. Stress divided by strain, and its formula already I have calculated. How much? F into L divided by A into delta L. I hope you are getting this, students. Now if if what is delta L I will write as L alpha delta T, so F into A. What I will write delta L is L alpha delta T, and here it is L. From here L and L will get cancelled. What we will get? F by A alpha delta T. This value of Young's modulus we are getting. Okay, so now you see which option is correct. F by A alpha delta T. Option C will be the correct answer for this question. Getting or not? Simple question, students. Simple thing. If we will increase the temperature, then the length of rod will increase. How much it will increase? It will increase by L alpha delta T, where L is the original length, alpha is coefficient of linear expansion, delta T is the change in temperature. I hope you are getting this, students. So this questions is very easy, and now I am going to end this session here. You please practice questions as much as possible. Again, I am repeating, this chapter can be bonus for you because number of concepts are very less. So practice as much as possible, as if maximum number of questions you have to practice here. Getting or not? Thank you very much.